Alrighty, so velocity handout B. Do I need to do all these questions? Like, I think number 1 is pretty straightforward, eh? No? Acceleration is the rate of change of speed. Acceleration is what kind of quantity, Chris? Oh, I thought you didn't know these answers. What is deceleration, Chris? So why do I need to go over them? A certain car is accelerating at 5 kilometers per hour per second. Explain what's happening to the motion of the car. Every second, its speed is increasing by 5 kilometers per hour. Give an example of a moving object that has a velocity vector and acceleration vector in the same direction and one that has them in opposite direction. So same direction would just simply be, use a car, it would be what? Car speeding up. And opposite direction, partner? Come on. Slowing down, right? It's going this way. The acceleration is behind us, so it's slowing down. Can an object, this is number 4 now, can an object be moving at a constant speed and accelerating? No?
Yes.
Yes.
It's taking a curve at a constant speed and it's accelerating as projection.
Very good. If you're taking the curve there at St. Rose, you're set at cruise at 100 and your speed maintains the same at 100, but your direction changes, you are accelerating. Which direction, Nicole, extension there, which direction, if you're making that St. Rose turn, right, you're going south towards McCurry, which way is the acceleration? Is it towards the right as you're going around the corner, like to the inside of the curve, or is it to the outside of the curve? Outside of the curve? Okay. You know? You don't know? I don't know. Anybody else want to try? Pardon me?
Inside.
Why do you say inside, Hunter?
Because you're turning into the inside. You're already accelerating forward, so you'd be.
Okay. So I'm just going to draw here. Okay. So there's the direction of the car, right? Right here. Here's St. Rose over here. Right. McCreary's down the road here, and we're going that way, right? So Hunter is saying that the acceleration is that way. I guess really there's only 2 options. It's either inside or it's outside, right? If it was a force, like if you had to push something in that direction, which way would you have to push?
Inside.
Inside, right? So could the acceleration be the opposite way? Like if I push something, isn't the push and the acceleration in the same direction? I think it has to be, right? So which way is the acceleration? Inside. Hunter's right. Okay. This is uniform. This is circular motion. We'll be dealing with that in unit number 4 or 5. I can't remember which one it is. Okay. Very good. What would be the shape of a speed versus time graph for an object in free fall? Okay. So Tom Petty jumps out of a plane, and he gets into free fall, right? It's not John Mayer. And not even a smile soundtrack. Okay. Got a VT graph, free fall. What would the shape of it be? Speed versus time graph. What would it look like? Darren, what do you think? Free fall. Jump out of a plane.
Be like that.
Up?
Like you're.
I'm gonna guess at what the motion that you made. Is that what you mean?
Yeah.
Okay. Jesse, what do you think? For me? Same thing? Okay. Lindsay, what do you think? That one's good? Now let's go along with that. Well, I'd say it's pretty close to right, except that it really should be downwards. So, Hunter, I think, was it you and I had this discussion yesterday?
It's negative.
Yeah, so it would really probably be like that, that's all, right? Because you're falling right, so the velocity would be negative, right? Yeah, well, I'll give you that one. Now, would it be a sharp corner like that, or would that probably be curved? That would probably be curved, yeah. Alrighty, that's number 5. What's the relationship, this is number 7. What is the relationship between speed and velocity? This one's pretty straightforward. Velocity is simply, Braden, velocity is simply speed plus direction. Speed plus direction. All right, probably number 8 I do need to have a look at, right? Number 8 refers to figure 3.5. Figure 3.5 looks like, where is it? This one here. And Courtney, I think this is the one, was it you that I was talking to yesterday? Okay, so it's kind of like that. And C and D are kind of right there and kind of right there, right? Alrighty. So, over which interval did the object have its greatest velocity? Over which interval did it have its greatest velocity? Let's just go by seconds, right? So would it be like 0 to 2, 2 to 4, 4 to 6, 6 to 8, or 8 to 10? Now, first of all, what kind of graph is this? Calvin, what kind of graph is this? Easy question here, right? What kind of graph is it? Position time graph. Very good. Okay, so the velocity is the slope or the values on the graph? The slope, right? So when does it have its greatest velocity? Well, that's when it's got its greatest amount of slope. So I think it's pretty clear that it's going to be between 4 to 6 seconds. Between 4 and 6 seconds, it's going to have its greatest slope. Over which interval was the object's velocity decreasing? When was the velocity decreasing? That would be when the slope's doing what? Flattening out? So when would that be, Nicole? It might even be more than one, right? Would you say and 8 to 10?
Yeah.
I think so, right? So maybe we should say 6 to 10. You're right. Good. Over which interval was its speed increasing? Well, when the slope's getting steeper, so certainly 0 to 2, 2 to 4, and I would even say 4 to 6. So let's say all the way from 0 to 6, right? Darren, is there any point when this object is traveling backwards? He says with confidence. No? How would you, what would it look like if it was going backwards? Would it have to be, the slope would be negative, or would the value of the graph have to be negative? Like if I happen to say continue this graph, let me just get this out of the way. If I continued the graph, let me just give myself a little more room. Would that be going backwards? Or does it have to be down here to be going backwards? No, this is right. This is going backwards. Because remember, it's a DT graph, so we're talking about the slope being there. What you're thinking about, Courtney, and I did throw you a bit of a curveball. What you're thinking about is VT graphs when I tried to fool you with stuff like that, right? And I asked you, is that going backwards? And the answer there is no, because it's a velocity graph and it's positive. That's okay. Okay. Well, I'm a sneaky fellow. I was told yesterday. Number 10. Sketch a graph of motion, distance as a function of time that would correspond to the following bicycle trip. You start your bicycle from rest. Increase your speed until you reach a comfortable traveling speed. You continue with this speed for a few minutes and complete your trip by slowing down uniformly through stop. I'm going to need a big space for this. Okay. So I'm on a bike. I start from rest. So you would assume that where I start is my starting point. So starting to rest means that it's going to be flat, and I'm going to increase my speed until I get to a comfortable speed. I do that pretty poorly. All right, so it's curved and comfortable speed that I'm going to keep at. How would I show that?
Straight lines.
Okay. Yeah, you're right. I was expecting you to say, yeah, no, I was thinking about something else. Straight line, right? When I wanted to get at there, that should be straight. But I wanted to get at, when kids say straight, sometimes they really mean flat. You didn't mean that, did you? No, good. That's what I was expecting, and I got confused myself. And then if I'm going to start slowing down, what's that going to be like? Going to flatten out. Yeah, pretty straightforward. Pretty straightforward. Okay, so there are the answers to velocity handout B.